Hello everyone. In today's session, I am going to discuss about our project that is Arduino based stepper motor controller. These are all the agenda that we will discuss throughout this presentation. So let's discuss one by one. First of all, let's see what were our key objectives during making this project. Our controller should be very easy to control, that anybody can control it. The compatibility, that means our controller should be compatible with all kinds of the bipolar stepper motor. The cost of the controller much more less that anybody can afford it. And the last one is all-in-one, means all the parameters of our controller of a stepper motor can be controlled by using this single controller. But the one question that may arise in your mind, there are regular DC motors available in the market. So why should we use the stepper motor? For better understanding this topic, I have compared the stepper motor with a regular DC motor. A stepper motor has some advantages over the regular DC motor. That means number one is precise control. That means speed, direction, etc. parameters can be controlled very precisely in case of the stepper motor rather than a DC motor. The torque of a stepper motor is high compared to a DC motor. In case of the DC motor, to produce the more torque, you have to use the gear mechanism. The constant speed is another advantage of a stepper motor rather than a regular DC motor. In case of the high or low loads, the speed of the stepper motor remains almost constant. The reliability of stepper motor is much more rather than a DC motor. Now, let's discuss why we need a stepper motor controller. In case of the DC motor, we only need a supply, a regulated supply or rated supply. But in case of the stepper motor, we have to use a special stepper motor controller because of the working of the stepper motor. If you notice the working of the stepper motor or movement of the rotor of the stepper motor, you will see that you have to feed the pulses sequentially on the stator windings. And in case of the bipolar stepper motor, there are two stator windings. That means for controlling these two stator windings, we have to build up a switching mechanisms. We can build up these switching mechanisms by using the manual switch or the switching devices like SCR, transistor, MOSFET, etc. But you can see over here that for controlling a single stator or single stepper motor or a single rotor, we have to use 8 in total switching mechanisms or switching devices. So that is less efficient and more costly also. For that, a controller, a bipolar stepper motor, we generally use a stepper motor controller, which makes the operation much more efficient and the cost also reduce. Now let's discuss some features of our prototype. We are providing the LCD display for better visual navigations and the numerical and alphabetical letters, that is indicating the speed and positions, direction, microstepping, etc. parameters. And definitely the ease of use. Ease of use means anybody that have or haven't any knowledge about the programming or the stepper motor will be able to use our stepper motor controller very easily. No need to prior knowledge about it. The compatibility means our stepper motor controller is compatible with all kinds of bipolar stepper motor. No need to change any circuitry. It is just like a plug and play. And our stepper motor controller has been built upon the 3 mode mechanisms. I will discuss the 3 modes in the operation section. But right now, you can understand it like in 3 different modes, we can operate the stepper motor in three different kinds of behaviors or in three different ways. So before going into detail about the operation, let's discuss the PCB layout. We have designed this PCB in the EasyEDA software, and this is a custom designed PCB. Within this PCB, there are three sections. One is power section. The left side of the power section is the manual control and right side is for the automatic control. In case of the manual control, we generally control three parameters of a stepper motor, that is speed, direction and the holding torque. In case of the automatic control, we generally control the rotation as well as we will also see the three mode control of a stepper motor. But during making this project, we have faced some problems and we have solved those problems also. So let us discuss some problems and the solution during making this project. As our stepper motor controller is the Arduino based, and you know that there are four types of Arduino boards available in the market. So our first challenge was which one will be chosen. Now here we have disqualified the Arduino Mega. We haven't chosen it because of its big size. We also wanted to make it as more compact as possible. We also haven't chosen the Arduino Nano and Pro Mini because the current pulses that will be fed in the stepper motor driver or control a stepper motor is less, it's not sufficient. But we have chosen the Arduino Uno. Now you might ask me a question. Arduino Uno is not so large and also not so small. So to make it more compact size, rather than using the total module or the total board, we have used the IC only. Means the IC of the Arduino Uno, that is the Atmega 328P stepper motor controller only. Okay. Now the second challenge was selection of the proper stepper motor and the driver. You can use any kind of the bipolar stepper motor, though we have used the NEMA 17 stepper motor. And you know that NEMA 17 stepper motor works as a high voltage, that is the plus 12 volt, and the high current also. Along Arduino, a single Arduino Uno cannot provide that high voltage and the high current. So for that, we have to use the A4988 stepper motor driver. You can use any bipolar stepper motor driver in it, but here we have chosen the cheapest one available in the market. Now A4988 driver have some limitations. Right now we have chosen the board, we have chosen the driver, but now the problem with the driver is this driver has some limitations. That means it can feed the maximum current of the 2 ampere. But you know that if the motor is loaded, the motor will start to draw more current. But if the motor start to draw the more current, then the 4988 driver will be burnt out. So that's why a proper handshaking mechanism is needed in between a stepper motor and a stepper motor driver. That means the rating of a stepper motor and the current rating of the driver should be matched. Otherwise, there will be the failure. Now, in our PCB layout, there are different components which are driven by different voltages. Like A4988 driver need the 12 volt, where Atmega 328P IC or the microcontroller needs the 5 volt. So to solve that problem, you can either use the buck converter, that is well-known buck converter LM2596, that can feed the current up to 2 ampere, which will be used here to step down the voltage from 12 volt to 5 volt. Otherwise, you can use the regulator IC 7805. You can use any of these two, but here we have chosen the 7805 regulator IC because of the low cost. These are all the components that we have used throughout this project. And for the communication channels, we have used these four components. Now, let's discuss the block diagram as well as the working principle. At first, I will discuss the manual control. After that, I will discuss the automatic one. In case of the manual control, as soon as we power up the Arduino, the LED will turn up. And after getting power, the Arduino will provide the signal voltages as well as the power lines, power supplies to the stepper motor driver as well as the LCD display. After getting the power, the A4980 stepper motor driver start feeding pulses to the stepper motor. And two switches, that is for clockwise direction and the anti-clockwise direction or the counterclockwise direction, has been used here to feed the digital pulses, which will be taken as an input. This input will be processed, and depending upon this input, the motor will behave. And a rotary encoder has been used to change the direction, to change the speed of the stepper motor. And now we will discuss the automatic mode of a stepper motor. Definitely the Arduino, as soon as we power up the Arduino will start feeding the pulses as well as the power supply. Will provide the power supply to the 16x2 LCD display and the NEMA 17 stepper motor driver. That means a 4988 driver. After getting the power supply, the driver will start producing the pulses, and three buttons has been used over here for different operations. I will discuss these operations later on, but these three buttons will provide the digital input signals. Depending upon these input signals, we can drive the stepper motor in different modes, and the stepper motor will behave like that. Now, we will discuss the simulations or the circuit simulations in online software. We have used the Wowkey software over here. At first, I will show the manual operation. As soon as we turn the display on, the default speed is 50, has been set to the 50, and the default position has been set to the 0. The position means is nothing but the shaft position over here. It is nothing but the shaft position. These positions can be controlled by these two buttons, one for clockwise direction, one for anti-clockwise direction. And you can see over here, we can reducing the speed or increase the speed by using the rotary encoder. After setting the speed by clicking on the clockwise direction and the anti-clockwise direction button, we can move the shaft position. And one more thing I want to mention over here, that is, while pressing the clockwise button, the motor shaft will rotate in the clockwise direction and the position will be positive. So positive means the reference is the default position 0. Depending, that means maintaining the reference 0, the clockwise direction has been counted as the positive position and the anti-clockwise direction is counted as the negative position. So that's all about the manual control. Here you know that in case of the manual control, you have to be in touch with the stepper motor controller for controlling the speed, for controlling the direction, etc. You have to be in touch with the stepper motor controller. But in case of the automatic controller, the scenario is quite different. Now let's discuss that. In case of the automatic controller, there is no rotary encoder. The command has been set by using three different switches. Here you will see the three mode mechanisms. By using the first switch, you can select the mode. In the set mode menu, you can select the mode. Just a minute. In the set mode, you can select the mode, and here we have selected the mode as mode 2. Okay. And you can also select the speed, and also you can select the number of rotation which will be produced by the motor previously. After setting all these parameters, you can come back to the main menu and turn on the motor. You can see the motor shaft starts rotating in the reverse direction. As we have set the rotation 3, that's why the motor shaft will stop after rotating 3 times in the anti-clockwise direction. Okay, that was the mode 2. And similarly, we can also drive this motor in the mode 0 and mode 1. I will discuss the mode 0 and mode 1 physically when I will show you the demonstration. Okay. So that was the simulation in case of the online. That is a Wowkey software. This is the physical controller picture of our project. This is the work plan that from the starting of July of 2024 and up to the May of 2025, whatever work has been done sequentially. This is the component list along with the prices. Now, you might ask me a questions. In commercial market, the stepper motor controllers are also available. Then why will you choose ours? So to understand, to make a clear vision about this point, you will see that uh, in case of the commercial market, for automatic stepper motor controller, that is costs around the 10,000 rupees. In case of the industrial automatic stepper motor controller. In case of the manual stepper motor controller, its cost is around 2000 rupees. What we have done over here is, we have merged both this automatic and the manual one in a single PCB or a single controller, by which you can use the you can control the two motors at a time, and as well as control those two motors manually and automatically at the same time by using a single controller. And the interesting thing is the price bracket. The price of our controller is only 2400, that is the manufacturing cost. So, which is obviously less than the 12,000 rupees. That is nothing but the summation of both individual manual and thus automatic stepper motor controllers available in the commercial market. So that is the most interesting thing, that is the price bracket. Now let us discuss what are the softwares that has been used throughout this project. Arduino IDE is the main software that has been used for programming. Proteus 8 has been used for designing or schematic designing. EasyEDA has been used for the PCB designing, and Wowkey software has been used for the simulation or the online simulation, whatever I have shown just a few times ago. For in case of the programming languages, we have used only the C++ languages that is used for programming the Arduino Uno microcontroller, that is the Atmega 328P. And like every product in the market, our product also has some disadvantages and as well as some advantages. The pros of our product is our controller has some LCD display for visual navigation. Our controller is compatible with any kind of the bipolar stepper motor, and all the parameters of any stepper motor can be controlled by using a single controller. No need to purchase a specific controller for controlling a specific parameter of a stepper motor. But the cons of our project is, our product is fragile. That is, the body is made of a 3 millimeter acrylic sheet. So that's why you have to take care about the damage. Our stepper motor produces some hiss noises due to using the cheapest stepper motor driver, that is the A4988 stepper driver. So this is little bit noisy and irritating also. And in long run, our motor starts hitting, and that's also due to using this cheapest stepper motor driver, A4988 stepper driver. Now these are some utilities or usages where you can use a stepper motor controller. In case of the home appliances, you can use this. In case of the commercial ATM or banking or ticket vending machines, you can use it. In case of the positioning tables, conveyor belt, in case of the industrial use, you can use a stepper motor controller. And like 3D printing mechanism, normal printing services, you can CNC milling machines, you can also use this stepper motor controller. In all these applications, you have to just use a particular parameter. You have to just control a particular parameter of a stepper motor. But by using our controller, you can almost control any parameter of a stepper motor. Okay. Like our product have been upgraded. Our product can be upgraded in future also. So that means I will discuss some future enhancement of our stepper motor controller. That means the low noise, whatever I have told, it is a problem of our stepper motor controller. This low noise can be removed by using a high quality stepper motor driver. And our controller can be controlled wirelessly or remotely by using a cloud mechanism or using the ESP boards. That means the Node MCU boards. For the conclusion then, whatever we have learned, we learned some hardware integration. We have improved some problem solving skills because during making this project we have faced many problems and we have found the solutions also. And we have improved our programming skills also. That means we have done the Arduino programming using the C++ languages. And flexibility is one of the most important parameter of our stepper motor controller. Our stepper motor controller can be reprogrammed. As you can see, the Atmega 328P IC can be removed removed from the IC base of our controller. You can reprogram any Atmega 328P IC just by knowing the connections and use it. These are all the references whatever we have used during making this presentation. Yeah, that's all for now. Hope you enjoyed this video, enjoyed this presentation. Your feedback is very much helpful. If you can give us the feedback, give the feedback us by using the Google form. The Google form link has been provided over here. If you have any doubt, any questions, you can communicate with me via this mail ID. And this whole presentation has been uploaded the YouTube channel and link has been provided here so that you can check it out. So that's all for today. Have a nice day.